Hi, I'm Hemel, and this is string theory in 3 minutes. So string theory, according to many scientists, is the strongest candidate for the theory of everything. This is a theory that would unite quantum physics, or the physics of matter and energy at atomic scales, and general relativity, or gravity. In order to do this, you would have to come up with a single theory that could unite all the fundamental forces of nature. These forces include gravity, which is a force that causes bodies with mass to attract one another, electromagnetism, which is a force that governs the interactions between charged particles, and the strong and weak nuclear forces, which make atoms behave and look the way they do. Finding such a theory that will unite all these four fundamental forces remains one of the biggest unsolved problems in all of physics. Okay, so now let's get into the basics of string theory. Firstly, we all know that atoms are made out of protons, neutrons, and electrons, and that these protons and neutrons are further made out of quarks. Well, string theory states that these quarks are really just one-dimensional strings of energy that vibrate at a certain frequency to create the particles we observe in things such as particle accelerators. A bit like a guitar, where each string has some tension and is given energy, or strung in this case, to create a certain sound. In a similar manner, particles can be thought of as musical notes or excitation modes of elementary strings. Unfortunately, these strings are way too small for us to observe. They're around the length of a Planck length, which is a millionth of a billionth of a billionth of a billionth of a centimeter long. Now, scientists actually came up with 5 different string theories that don't fit together very well. These focus on bosons, which are particles that transmit forces, and some of these also add in fermions, which are particles that make up matter. Some string theories make an assumption about the universe called supersymmetry, which states that for every fermion in the universe, there is a boson, and vice versa. Supersymmetry simplifies string theory equations by allowing certain terms to cancel out. Without supersymmetry, these equations result in many physical inconsistencies, such as infinite values and imaginary energy levels. The thing is that scientists have realized that all these different theories that seemingly don't fit together very well are actually just different representations of the same thing and are part of a bigger theory called the M-theory. Now, mathematically, this M-theory requires 10 different dimensions of space and 1 dimension of time, which is really hard for us to imagine because we can't experience anything other than length, height, and width, and the 1 dimension of time, obviously. There are 2 main theories that try to explain this. The first states that these extra dimensions are compactified such that we can never observe them. A bit like how from a distance objects seem as though they only have 2 dimensions, however if we get close enough, we can tell that they actually do have 3 dimensions. The second states that our universe is on a brane or membrane, and that this brane is part of a higher dimension of other branes, each containing their own universes and dimensions. Think of a library, where each shelf represents a brane with its own dimensions, and each book represents a universe on that brane. But that's a topic for another day. Currently, there is no resounding proof that instates string theory as the theory of everything. But who knows what the future may hold.